Welcome to this second video clip in support of our improvisation lesson. While the focus of the first clip was on our playing and looking at ways to use scales in improvising, the purpose of this one is to investigate the relationship between scales, chords and keys from a theoretical standpoint. Having a good knowledge of how and why these three elements relate to each other, both a formulaic and musical context, will help you massively in your improvising, because it enables you to build a wide-ranging vocabulary which you can access during jam sessions. It also gives you a greater understanding of harmony and melody working together. Put simply, which notes will sound good over which chords. I'm going to be dividing this lesson up into three sections. Section 1 will be looking at the construction of the major scale. Section 2 will be harmonizing the major scale and the chord functions from the chords that we get from it. And the last section, section 3, will be constructing scales and their application in a chord progression, basically how they sound over chords. Firstly, let's look at what is probably the most important scale in Western harmony, the major scale. If we analyse how the scale is constructed in terms of intervals, an interval being the distance between any two notes, we can see that the stepwise order of tones and semitones is as follows: tone, tone, semitone, tone, 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 semitone. This is basically the formula for constructing the major scale, and no matter what note you start on, if you strictly follow this formula, ordering consecutive notes using this series of tones and semitones, you will always end up with the major scale. Let's first of all try it starting on the note C. Following our major scale formula, the next note up needs to be a tone apart from C, which gives us D. Now another tone, which is E. This time it's a semitone step, which is F. And then a tone, which gives us G. Another tone, which gives us A. Another tone, which gives us B. And finally the last step is a semitone, and we arrive back at our root note, which is C. This gives us the C major scale. And when we talk about a piece being in the key of C major, what this actually means is that this scale is the basis for all the chords and melodies used to compose that particular piece. As opposed to memorising the series of intervals using the letters T and S, and the order of tones and semitones they represent in making up a particular scale, we assign numbers to each degree of the scale, as this offers us far greater clarity in analysing it. In the major scale, it is simply the numbers 1 through to 7. And one of the main reasons that the major scale is of such importance in studying theory is that the numbers 1 to 7 that we assign to it are used as the basis for all other scale formulas. We either select, omit, or alter certain numbers in various ways in order to obtain the formulas for other scales, such as the pentatonic major and minor that we've been using in our lesson. One other important rule to take note of at this point is that in a 7-note scale, such as the major scale, each note letter needs to be represented, i.e. each of the 7 degrees of the scale has to have one of either a C, D, E, F, G, A and a B in its name. Those letters have to appear once and once only. This is where we have to start using sharps and flats when constructing major scales and keys other than C, in order to meet this rule, as well as strictly follow our major scale pattern of tones and semitones. Just to remind you, the order of the intervals are what actually gives the major scale, or any scale for that matter, its distinct sound. So let's try this out and construct a major scale in a different key. We'll use the key of G, as that's the key we've been using in our improvising lesson. Our starting note, our root note, and the note that defines the key and gives the key its name is of course G. Following our major scale formula of tones and semitones, the next note is A, then B, now semitone to C, D, then E. Now this is where we start to see why we have to use sharps and flats sometimes, known as accidentals. We can see that we need to follow our scale formula to maintain the order of intervals that make up the major scale, and we also need to represent the note F in some way. The interval distance from E to F is a semitone, but our major scale formula requires our next note to be a tone away from E. If we chose just a standard F for our next note, or an F natural to give it its technical name, we would not be following our scale formula and we would not end up with a major scale. The F natural is too narrow an interval. In this instance, it's too narrow by a semitone. So what we have to do to solve this is to raise the F to sharpen it by another semitone. We call this note F sharp. Finally, we move up the last semitone step to arrive back at our root note, the G. We now have our complete major scale in the key of G, which is made up of the notes G, A, B, C, D, E, F sharp and G. Let's now look at our two scales from our lesson, G major and G minor pentatonic, and how we derive them from the major scale. First of all, we need to remember that the degrees of our major scale are assigned the numbers 1 through to 7. Now here are the scale formulas for the major and minor pentatonic. Let's take a look at these in more detail, especially the minor pentatonic scale formula. Now, deriving the major pentatonic from the major scale is relatively straightforward. We take the scale degrees of our major scale, 1, 2, 3, 4, 5, 6 and 7, and knowing the scale formula for the major pentatonic is 1, 2, 3, 5 and 6, we select them and there we have our major pentatonic scale. In the key of G major, these notes would be G, A, B, D and E. So when we play melodies and solos using these 5 notes, it gives us the major pentatonic sound. Now, deriving the minor pentatonic from the major scale is a little trickier. The formula for this scale is 1, flat 3, 4, 5 and flat 7. You can see here that we're having to apply some accidentals on some of the scale degrees. For the minor pentatonic, these accidentals are used to flatten the 3rd and 7th degrees. So our minor pentatonic in the key of G, first note, the 1, is obviously G. The next note in the formula is flat 3. This means that we need to take the 3rd degree of the G major scale, which is the note B, then we flatten it by a semitone, which gives us B flat. Next is 4, C, and 5, D, and finally the flat 7. So we take the 7th degree of the G major scale, the F sharp, and we flatten it by a semitone, which gives us F natural. That's what flattening a note essentially means, is you lower it by a semitone step. So there we have our G major and G minor pentatonic scales complete, using the scale formulas to derive them from the parent key major scale, which obviously in this case is G major. Just remember that although we are working with the key of G major as an example here, due to it being the key we used in our lesson, all these formulas are applicable across all keys, not just G. For the next section, we'll look at how we construct chords from the major scale and how these chords, or the harmony to use its technical name, work together in a progression such as the G, C and D chords we used in our improvising lesson. And they act as the underlying harmony over which we compose melodies, including our improvised phrases. The most basic form of chord and the building blocks of harmony is called the triad. It's relatively simple to create triads on each degree of the major scale, and this is called harmonizing the major scale, by following a couple of simple rules. Firstly, to build a triad, you just have to add or stack notes on top of each other in intervals of a third. And secondly, each note used to build the chord must be contained within the major scale. Let's do this still working in the key of G major and starting on the first scale degree. Obviously the first note's G. Next we add another note using our 2 rules stated previously. A note that is a third away from G, and also ensuring that the same note is found in the G major scale. So a third interval away from the note G is the note B. And you've got to ask yourself, is this note also part of the G major scale? And as we can see illustrated here, yes it is. Now to complete the triad, we need to repeat this process for the note B. So a third above B is the note D. And again, is this note contained in the parent major scale? And we can also see here, yes it is. We now have our first chord, the G major triad. Incidentally, another way of constructing triads on each degree of the major scale is to stack alternate notes from the scale on top of each other. This is essentially what stacking intervals of thirds is. I personally think that whilst thinking in these simple terms can help, it's also important to know technically what you are doing in terms of interval distances. The next note in the scale is A, and if we stack intervals of diatonic thirds, diatonic meaning only notes belonging to the key, in this instance the notes from the G major scale, we get the notes A, C and E, which make up the chord A minor. If you repeat this process on each scale degree of the G major scale, you will end up with the chords G major, A minor, B minor, C major, D major, E minor, and finally F sharp diminished. Just as we assign numbers to the degrees of the major scale to help us as a formula with which to apply to different keys, similarly we assign Roman numerals 1 to 7 to each chord built on the degrees of the major scale. This helps musicians to clearly communicate the function of each chord in a key and a chord progression with each other. In the major scale, the pattern of chords built on the scale degrees is thus: first is a major, second minor, the third scale degree minor, on the fourth scale degree major, the fifth major, the sixth minor, and the seventh diminished. The property of a chord being major, minor or diminished is called its quality. So in the harmonized major scale, that is in a major key, the pattern of chord qualities is always this: major, minor, minor, major, major, minor and diminished. So if we look at the chords we used in our improvising lesson and match them against their Roman numeral function within the key of G major, G is 1 chord, C is the 4 chord, the D is the 5. So if we were to communicate this to other musicians that you were playing with, you would say that the progression is 1, 4, 5. So what would be the benefit of talking like this rather than saying G, C and D? Well, the answer is, as I alluded to earlier, using the Roman numeral functions to denote chords within the key means that you can communicate their function in a progression, and importantly in any key, without any ambiguity. As an exercise to try, write out major scales and harmonise them in different keys, then learn what each chord function is in each key. Finally, we will briefly look at the relationship between the 1, 4, 5 progression and our major and minor pentatonic scales. You may ask the question, why use pentatonics? Why not just use the major scale? Well as pentatonics having a different characteristic sound to the major scale, they also have a great advantage to the beginning improviser in that there are no notes in the scale that will sound unpleasant or too dissonant when soloing over the chords that we have created from the major scale. Here's a diagram depicting our 1, 4, 5 chord progression in the key of G major, the notes that make up those chords, plus the major pentatonic and minor pentatonic scales in the key of G. Some scales, such as the major scale, contain what we might term an avoid note. That is, a note that when emphasised in a melody at a certain place in the harmony, it may sound unpleasant or out of place. And as this diagram illustrates, using pentatonic scales in a 1, 4, 5 progression avoids this potential hazard. Basically, playing the major pentatonic scale over any key in a major 1, 4, 5 progression will sound good. There are no avoid notes. However, not all note clashes, what we call dissonances, are unpleasant. When we use the minor pentatonic over our major chord progression, we're blurring the lines between major and minor tonalities. What we're doing is essentially forcing a minor sound over a major harmony, and this is what we've come to commonly hear as the blues. You can see that the flat 3 and the flat 7 contained in the minor pentatonic scale will create some kind of dissonance against the natural 3rd and natural 7th found in the harmony. This is an example of desirable dissonance used for musical effect, particularly in genres such as blues and jazz, with the flat 3 and the flat 7 actually being labelled the blue notes. And as this last slide illustrates, the minor pentatonic scale here also contains the note C, which in the major scale we deem to be an avoid note. So the obvious question to ask is this also an avoid note? The answer is no, as when it's used as part of a minor blues tonality, it is much more effective and desirable as a note to include as either a passing note or an emphasised one when we're soloing or creating melodies. In the context of major harmony, it has a much greater dissonant feel. I hope you've enjoyed this theory lesson, and I also hope that it's given you a greater understanding into the relationships between harmony and melody, as well as tips to help you improve and develop your improvising and general musicianship.